The optimization of the load balancing can be done in the most efficient way if that has been chosen wisely. So pertaining to that, the fuzzy randomized approach is a better alternative to do that, and it requires the system to look into that the number of that cloudlets upon which that operation need to be performed. So those cloudlets are to be provided to the data center where the balancer has to use the applied approach which provides that which virtual machine would be the best suitable for the which application. Pertaining to that, the challenges are there that the machines which are being used are geographically separated apart and they are not connected together. In that case, our that are only connected through that data center. So here in this, the challenges are pertaining to that are that the size and the resources, the availability of the resources, and the distance, bandwidth, hard disk space, and memory space, the number of processors that are required. All these are the multiple constraints that has to be looked into while deciding that which which virtual machine would be the best suitable. So unlike that static mode where we have to just choose that a particular machine in the specified area or the locations upon which that operation need to be performed. So in that case, the network operating center in charge has to assign those resources for on that machine, which we could not claim that is based on that cloud-based server system. So in this, the large network operating center where that the data center having there could be the multiple number of the data centers that are connected together and the applications using which has to be applied to on the multiple virtual machine. Pertaining to this, that the work has been published in the LeadCon conference in Central University, Delhi. So, as as I said that in the previous lecture, that the static implies that nothing is changeable and you just requires to opt whatever that has been assigned. Whereas the dynamically we can opt that which one would be the best suitable and based on that the task can be assigned. Pertaining to that, the further challenges are there that the task which you are expecting to be run, in that case, whether do you require to have the quality of the services. I mentioned that there are the two variations over there. The one is that the best services and another is that the quality throughput. Okay, so in this, the best effort or the best services implies that whatever the resources and the uh, 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 bandwidth and the space that is available, so you require to use them to perform that fast as much as possible. Whereas in that the guaranteed throughput that implies that the resource, time, response, throughput, reliability, all should be monitored and controlled, and based on that, the minimal performance object output should be there. If it is not been there, in that case, we require to ensure by that service provider that those type of that target are not being made. So in that case, it has to do that to ensure that the quality outcome should be there. Pertaining to that, the ratio need to be defined. Let us say that having a 10 Mbps, or let us say that nowadays it is common that 100 Mbps, 200 Mbps, 300 Mbps speed that is to be expected by the access point using which that node is to be connected. So in that case, that minimal accessing time and the response time that should be there. That may require a lease line, that may require a dedicated path using which that operation need to be performed, and that may require certain security that should not be breached. So pertaining to that, the one level we think about such type of the scenario. Another is that having those type of the layout and the resource available, I must ensure that the task should be complete and that has to be given me that minimal response time in order to execute the task. So the throughput should be high, that the number of tasks that can be completed within that stipulated time. So that would be referred to as a throughput. And and it would be varying based on that the type of the resource requirement and the type of the applications among the different user. Another important constraint pertaining to this is the cost. So cost is in all aspect are the part, whether you are using the dynamic load balancing or the static with the quality of the service or without quality of the services. Pertaining to that, the cost is always be there. So in that case, the amortized cost implies that whatever that cost, if the $3 if it is to be used to establish that applications and applying that resources over them. In that case, whatever that operations you want to do and that the data which you are taking or using to and from pertaining to that, the $2 will be there and the $3 will be that initial values. And the $1 will always be used as a part of the emergency where that has to be applied. So in that case, uh, the updation deletions would be of that $2 cost. So pertaining to that, the pricing and the model that would be varying based on that the service provider and the location and the type of the services which are needed by the user. Another aspect of this is that based on that workload and the need and requirement, I may see further extension of the data, further size of the data that need to be used to compute or to give me that deep learning approach. If I'm applying in that case, the large data set is expected to be used, and there the testing and training data is to be applied. There, the size of that data is a important one. So in that case, the use of that would be there and that need to be applied. So in that the load which is to be carried out by the machine may not perform well if the data is too exhaustive. Unlike that is been used in a generalized and simplified way of the machine learning technique. So in that case, all those tasks which has to be operated upon the machine require a supervised learning where the data corpus size is very large. We requires to refer that as a dynamic workload where the multiple resources based on that requirement should be added with the current allocation of the resources, and the size of a data system would be increasing based on that need and requirement. So in that case, the efficiency of the system would be that it has to assign those add-on resources based on that need and requirement. So dynamically updating the resources, dynamically updating the data set, dynamically adding much more resources to compute that task would enhance the performance. In that, it requires that the data center must have those type of that sufficient machine available, that the task execution pertaining to that operation based on that applied API would have to complete that in a parallelized way. So pertaining to that, the OpenMP MPI type of that directives that has to be enabled and added with that task. Based on that, the parallelized operation can be performed. In this, the load balancing is may not be confined to the single data center, but that would be referred to that multiple number of the data centers. As I said that when I visited the Cognizant data center way back while visiting at the IIT Madras, they took to us to the Cognizant Center and they stated that we have this fixed lease line, and using this data center is connected to the two other data center in India itself with a different location, and the replica of the server which is being currently being used by the industries and the banking services, banking bankers or banking network, that replica of that is also available over there. So updations and the concurrency and the switching of the data to update the record, that is a very critical one, and that has to be done without any for delay. Pertaining to that, the challenges are there, so that has to be met in the precises with that the time interval on that assigned interval. So having those type of the challenges available with those type of the constraint, we require to focus on that. If we apply the fuzzy based type of that rule based type of that logic system where the resources can be allocated based on the certain set of the rules, which would be the best fit having those resources available. The load balancer will have to take those type of the machine, the task and assign to those machine. So pertaining to that, the optimized fuzzy load balancing algorithm first assign those type of the threshold that this much of that efficiency of the machine would be, and how many requests that can be handled, and the tasks which are to be operated upon that has to be queued in, and the data center controller which are connected together has to be initialized and it should be ready and should be available to access those requests, and based on that it requires to assign the machine. And now the machine may be available, that may be busy, or that may be exhaustively busy. Pertaining to that, the variations of the busyness or the status can be defined and that can be used. So having that the list of that machine available that can be used, the parameter constraint with upon which that decision has to be taken by the data center would be the memory bandwidth and the disk. So three parameters currently that has been defined over here. So in that case, the fuzzy inference system taking on those parameters and the rule base which is to be assigned, it takes those input data from the user and assign and look for those that whether this data is meeting the need and requirement and the specification of the available virtual machines. In that case, the task would be assigned to them and that is to be allocated. So the for this allocation, the machine would perform the task. Now that task, once that gets free, this information has to be propagated to the controller, and the queue of that has to be emptied, or the task which is already been done. In that case, that task entry should be exit from the queue. Could happen that the task may be entered as a part of the priority pertaining to that separate queue need to be mentioned, and those tasks which is already in the queue that has to be added added in that separate queue, and that has to be performed in the order. So in that case, the optimized fuzzy load balancing would not only give the variations of that constraint available based on that which machine would be the best available pertaining to the task that has to be that need to be performed, and and the machine is being chosen from the list, and it could happen that once that machine is been assigned, in the case that has to be entered in the busy list. So the virtual machine status has to be indicated, and that has to be marked on that a certain task has been given to the certain machine, and how much further space that can be available, whether the other task can also be assigned to them. If that is also been there, in that case, the based on that feasibility of the available of the resources, based on that bandwidth, memory, and the disk, or further that the processing power, further that the speed, or the frequency, certain further parameter can also be added. So in that case, implying that the three main parameters that has been considered over here, the queue are to be processed, or the tasks are being processed uh, as per that entry in the queue, and in this order all those tasks has to be completed. Now once that task has been completed, the resources need to be get free, and pertaining to that, the status of the busy virtual machine should be changed to the available of the machine, and the further additional task, if it is been required, in that case that machine can be allocated for that task based on that fuzzy based rule. So this is what that operations that need to be performed. Pertaining to that, as I said, that for these three different type of the variations, now here the memory of the five different stages that are being defined: low, uh, very low, low, medium, high, and very high. Okay, and in that the range of that has been defined that if the requirement X is related to that range, in that case, which machine would provide such type of that memory as per the need and requirement. The higher the memory requirement, the larger the space ought to be there. And if that does not meet, in that case, we'll have to wait for that. In that case, the waiting time would be varying. In that case, uh, the task that would again depend on the task which are being available, which are being performed by the machine, and that ought to be done by the machine. So here that another part is this bandwidth. So bandwidth again is having this five different type of the parameters. So 5, 5, 25, and 25, and in that case the third is that's a disk space. Bandwidth and the disk space. So the low, medium, high, and these are three different parameters that are there. So in that case, 5, 5, 25 into 3, that is 75 sort of the rules that would be created. So in that case, having these 75 based rules available to decide that which machine would be the best suitable for to perform the task, and that can be assigned. We can go through that, and that will give us that near to that optimal solution. Likewise, that has been stated over here that this task, because of that, the simulation work pertaining to this would be shown over here. Once I will have to specify that what is been done in that machine simulation work that the Madhav will explain you. Madhav, are you ready?
Yes, sir.
Okay, good. So I will just try to finish that as early as possible. So pertaining to that, a number of the requests that is to be assigned to the data center, the data center, the controller has to, or the load balancer has to apply the algorithm, and based on that algorithm, the task should be scheduled and that can be assigned. So here that OFLB is to be used, and that the availability list, it checks on its uh, list or the memory, and has to determine that which machine would be uh, free or available on which that task can be scheduled. So in that case, the allocation of that resource would be assigned to perform the task, and that has to be marked. So pertaining to that, if another task which arises, it has to look for the feasibility that which one would be the best suitable on that available list, and among them, if someone task which is already there, in that case, uh, and that machine is ready to or qualify based on that constraint that it can handle those task, in that case, and that is in that list, in the first come first serve basis. In that case, that machine would be allocated to that particular task. So the queuing threshold is also being used in order to determine that which one would be the best suitable in order to perform the task. So as I mentioned earlier, that the specification of those resource constraints are required to be defined, and in that the fractions of that would be giving us that flexibility which can be varying and changing. I can opt that what should be that the criteria for deciding the low, medium, high, or use whatever that parameter that can the user is flexible, or the data operating center controller is flexible to determine that, and based on that the task can be allocated. So pertaining to that, the multiple variations of that, in order to make that guaranteed throughput, this membership functions plays a very important role. So here this membership function for this guaranteed throughput is that having this 25% or the 50% guarantee that I need, that in that case I'll have to meet that requirement goes based on these constraints, and having those type of the constraint, because this is what that expectability or the desirability is, that कि मुझे जितना भी रिसोर्सेज है गारंटी तो दो कि 25% मेरे को मिलेगा ही मिलेगा, या 50% परफॉर्मेंस तो वो देगा ही देगा. इन दैट केस द टाइम स्पेंड वुड बी हायर or multiple of that. But if that 100% is there, in that case, that would be the best one. But the 50% or the 75%, if it has been available, that is a good criteria. Whereas that 25 to 50 is that situations where we are compromising with that availability of the resources, and the output would be depend on that how much times that machine would take based on that resource availability. So for this bandwidth, memory, disk, all these parameters that we'll have to set. I repeat again, this membership functions is pertaining to that the quality outcomes that is expected from that virtual machine or the data center has to provide, and based on that the outcome has to be determined. So this membership is ought to give us that expected output. So in that case, the cloud-based number of the tasks that need to be given to the machine, we will pass to increase them and then apply the variants of that approach, and make the comparison. In that case, you can see over here that the OFLB has been compared with the first come first serve or the shortage of first. You are all aware about this algorithm, and in this the OFLB, having that knowledge of that precise uh, specifications of the resources availability, it is outperforming compared to the existing one. So in that case, there may be the slightly variations in the defender. Sometimes the variation is too large to be accepted, and or that is quite variation is quite visible as a part of the difference, and in that case we'll have to consider that. So slightly variations in that performance would be giving us the better execution time. So if the execution time is low, in that case it implies that the resources are fully being utilized, and that is giving the better performance. So likewise, stated over here, which is the variations of this table, where a very small performance increase is visible and that can be clearly depictable in this table, whereas in such type of the graph, it is not clearly being mentioned, but it is a part of that level. So majority of these tasks which are been there with the larger number of the cloudlets or the task which has been assigned, the system is performing in that fashion and giving us the slightly better compared to the existing one. So this is what has been done over here. So I switched over to the Madhav to demonstrate you that how does this algorithm OFLB and the different algorithms that he has performed. How does that work and how does this task is assigned and how does the performance can be evaluated. So Madhav,
Yes, sir.
so now you please start demonstrating the simulation and
Yes.
experimental work.
Yes, sir.
So I request the participant that to go through that carefully because pertaining to that the challenges are there that the simulating environment pertaining to that the library support pertaining to that the command request and that limitation of that resource how much that can be used, those are also the part of the simulator work, simulation work. So in that case the sufficient amount of the space and that is there where that Madhav Khatri is performing this task. So the initialization operations and assigning of the task and the allocation of the resources based on those algorithms that shall be discussed by the Madhav. So please Madhav, start.
Yes, sir. Sir, the screen is visible.
Yes, it is visible.
Okay, sir. So, good evening to everyone, and it's an honor to be here in this faculty development program. And I am deeply grateful to my respected guide, Professor Mushtaq Ahmed sir, for his constant support and encouragement. And today I will be introducing CloudSim, a widely used simulation framework in an cloud computing research. And CloudSim allows us to model cloud infrastructures, test schedulings and load balancing strategies, and evaluate performance without needing costly real-world setups. So in this session, we will cover the basics of CloudSim and its architecture and how to use it for designing and testing custom policies. So let's get started. Now I'm coming to the same environment first. So in the previous uh, we have covered we have covered how to like let me increase the text size now. Yes. So first of all, I am coming to the previous example where we have introduced CloudSim and created a list, virtual machine list and crowded list. Okay. So in the last class, we have learned that how to create a clouded list, and after creating a cloudlet list, we have to create a linked list. Means in which we are introducing the list of virtual machines, and after creating the linked list we have to add one by one. The entire linked list is full of virtual machines, so for that we have to provide the VM parameters here. Okay. Now coming to the example, coming after completing, I have to first run this example again. Okay. Now so this example is running fine. Okay, and in the last class we have learned this, that how to run this setup. Now I am coming to the FLB part. Okay, so before going to this, I would like to share my slides. So let me share my slides. Yes, is my screen is visible? Is my screen is
Yes,
visible?
yes, sir. It is visible. Yes, sir.
Okay, so because going to the simulation, we have to see what is our objective. So the objective is we have proposed an optimized fuzzy-based load balancing scheme, and we combine the fuzzy inference systems with the optimized scheduling, and then we select the best virtual machines on the fuzzy constraints, and after that we reduce the execution time of uh, the optimized fuzzy load balancing scheme, and then we improve the efficiency and resource utilization of this scheme. Okay, so after this, in this fuzzy logic, we have introduced three variables: memory, bandwidth, and disk. And the FIS stages have been introduced: fuzzification, the inference engine, and deep fuzzification. In this, the algorithm part is already covered. Now, this is the algorithm which we run on this simulation. Okay, so receive job request, data center controller, and then OFLB checks the VM, and then the three membership functions has been introduced here. Then assigning job to the most suitable virtual machine. If the virtual machine is busy, then we again evaluate which virtual machine is available. Okay, so for the experimental setup, we introduced multiple nodes and varying clouds, like where from 5,000 to 20,000, we introduced the cloudlets. It means that we are increasing the task to the cloud simulator. Now I'm coming to the simulation part. Yes. So is my screen is visible?
Yes, sir, it is visible.
Okay. So now coming to the cloud FLB part. Here, yes. So here from the starting, I have same here. I have created the cloudlet list and the virtual machine list. Okay. So every time a new cloudlet has come, it is introduced into the cloudlet list, and for the virtual machine it is introduced into the, means every time a new virtual machine has came, the parameters has been decided, and then there these virtual machines are included into the virtual machine list. And after that we create a virtual machine, and these are the parameters we decided for the virtual machine. Like for the system configuration, we provided these parameters in the slides also. So here I have created the size of the virtual machine will be 10,000, means it's a local virtual machine, means you can change the size of the virtual machine, and we already discussed this part in the previous lecture. So I will directly run this algorithm. Before running this, I will introduce yes. So I'm coming to the tipper files first. Yes. So these are the fuzzy logic block which we have included in our slides. So here, this is an HCL file, function block tipper. We have declared the function block, and in this, yes. So yes. So here I have created three constraints, fuzzy constraints: memory, bandwidth, and disk. Okay. Now after creating these three constraints, we provided the output variable as VM status. Okay. Now the fuzzy memory, it's in, we are deciding the upper limit and lower limit for the membership functions. Okay. So for that, the equations is already written on the slides. For very low, 0 to 1 is decided. It's calculated in the slides. Already the calculation part is done in the slides, which will be shared with you. Okay, so these are the five constraints on the memory, fuzzy memory variable. Okay, so very low part, for the very low part, the upper limit is 7,200. Similarly, for the low part, means every time we are deciding the membership functions values. Okay, from it will be varying from 0 to 1 in the results. Now coming to the bandwidth, here this is the calculations is all already done on the using a membership functions. Okay, now these are the rules we have created from rule 1 to rule 75. Sir has already told you that 75 rules are there. So we created these fuzzy rules. If memory is very low and bandwidth is very low, disk is low, then VM status is very busy. Means every time we are changing the memory value according to the fuzzy constraints. Okay, so 5 into 5 into 3, it's approximately 25 into 3 is equals to 75. Okay, so sir has already told you that we have created these fuzzy rules. So according to these fuzzy rules, we just run this example here. Now coming to the CloudSIM FLB part. Okay, yes, so we have already discussed these parts. Okay, now I have to run this and first check if it is running fine or not. Now see these results. Okay, so results are coming, means every time we are checking the values of are according to the membership functions we have decided or not. Okay, so let me run. Yes, okay, so results are coming. You can see for the memory variable. Okay, the membership for the memory variable membership functions, the trapezoidal, because we have used trapezoidal functions for the tipper file. We have introduced different functions to conclude our results. Okay, so now we have using a trapezoidal function, the values are coming like from 5,000 to 35,000. Okay, the peak value is coming around uh, 7,200. Okay, so for the very low functions, it's coming 7,200 value for the memory function. Similarly, for the bandwidth function, the value is coming around 7,200. But see, this is the bandwidth functions are different and memory functions are different. So both these values are different. Okay? So you have to observe where the function is changing this value. Okay, so the black value will denote the highest means the value. The label is denoted by the X, and the highest value will be denoted by the red column. Okay, so this is the highest value, and the low value will be denoted by the blue triangle, and the very low will be denoted by the green triangle. Okay, so these functions are written according to these functions. We get the result, and here we can see the changes are coming. Okay, I'm just removing the security and network latency part here, and for these functions we have designed the uh, membership values. Okay, now to see the VM status part, 8.47 center of gravity part is coming 8.447. Center of gravity part means the where all the functions are coming, means all the function values where median value is calculated. Okay, so 8.47 will be the median value, and here uh, now I am again executing this function here. Now see, this is the code that we have written to execute this. So for this, we use JFuzzy logic library, and for the FIS fuzzy inference system, we included the FIS library here. Okay, you can download it from source post. From here, you can include these jar files in your program. Now coming to the uh, this is the code where we have included these fuzzy rules in our program. Okay, so FIS is an object which load the files. Now if FIS is equals to null, it will display the message cannot load FCL file. And every time we have to set the variable names memory, we take here 100. Okay, we calculated these values and check at which the threshold value the membership functions will be producing the results, like it's an optimized fuzzy load balancing scheme. So we have optimized the results using the threshold values. So these are the threshold values we have calculated. Okay, so here 100 is a threshold value, and by using 20 threshold value, 40 for the disk, 1 for the latency, and 1 for the security. We can exclude this network latency and security here. Okay, because both these functions are different here. For the OFLB task, we have included only three members: memory, bandwidth, and disk. Okay, now after evaluation, it will produce the results. Okay, VM status. VM status means at the last. So why we have written this code here? divide the list, because every time a total value is coming, means every time there is a bulk of task is coming, and the whole queue is full of tasks, means every time whenever a new task is came, it has to check where is the available VM and where is the busy VM. Okay, so we have separated the list to available VM list and the busy VM list. Okay, so now after running this chart again, I'm running this code. Okay, now see, I'm removing this security and network latency because it is printing both these values. Now see, every time it is changing according to the results. Okay, threshold value. So is my screen is visible? Is my screen is visible to you? So these,
The code is shown, but the output is not shown.
okay. Uh, let me again share.
No, just scroll that part. Madhav,
Yes, sir. Yes.
that coding part, you just scroll up so that the bottom side, that result will be depicted.
Yes.
इसको ऊपर करो.
Yes.
अरे इसको ऊंचा, इसको, अरे ये बार जो नीचे है ना, इसको ऊंचा करो आप.
Yes, sir. Yes.
हाँ, now this is visible.
So these are the fuzzy values which we will get after running this example. Yes. So is my screen is visible?
Yes, sir. Yes, sir. Not visible.
Okay. Now I will again run this code and see the results. Yes. Now it is visible. Yes.
Yes, sir. Now it is visible.
Okay. So here you can see here the I'm removing this network latency and security part. We will cover this in the extended version. We have included these two variables, but here you can see in the this part here the blue triangle is showing the lowest value in the membership for the membership function. Means we have calculated the membership value according to the we have first decided the threshold value. Okay, so for threshold values we have different algorithms we have run, and we decided the threshold values. After the threshold values, we calculated the lowest function. Means there are 5 constraints of the memory variable. Similarly, 5 constraints on the disk variable and 3 constraints on the bandwidth function. Means the whole functions, the whole function will be producing the results according to the threshold value. Okay, so now you can see the VM status part. Okay, so in this VM status part, the red triangle is showing the busy value. Okay, so we have two lists: available list and busy list. Means if a virtual machine is in the busy list, it will show in the red column, red triangle. Okay, so this red triangle is showing the busy VM list. Okay, similarly, the blue triangle is showing the available VM. Okay, so every time the task will be assigned to those machines which are available, and if we get the virtual machine is in busy list, we will shift that task to the available VM. So this the background yellow triangle is showing the moderate values. Okay, which are not in the very busy list and which are not in the busy list. So every time you can see here the peak value of the blue triangle, which is the lowest value. Okay, the lowest constraint here, it is approximately around 7200. Okay, if you calculate this triangle value from 0 to 15,000, we have these x values are representing the cloudlets. Okay, means every time we are increasing the cloudlet parts, and according to the cloudlets, we decided the threshold values, and after running this algorithm, we get these membership values. Okay, so now you can see here, similarly in the disk, for the disk, this blue triangle is showing the lowest value. Okay, so the lowest values which we are getting for the disk membership function. Similarly, here the green part is the medium values, means which are not in the highest part, and which are not, means it covers the entire x values. X values means the cloudlet values. Okay, so every time a task has come, it will be assigned to the data center broker, and the data center broker will decide that which machine will get that task. Okay, so there may be two virtual machines, or you can increase the value of virtual machines according to the number of cloudlets. Okay, so now I will again run FCFS code now, because we have different we have compared our results with the two different traditional algorithms. First is CloudSIM FCFS. Okay, so this is the first come first serve basis part. Okay, so whenever a cloudlet has come in the algorithm, we have seen that the first come cloudlet has been served first, means a cloudlet has come in the list. The first one is assigned to the machine first. Okay, the virtual machine will get the first cloudlet. After the completing the task, the first task will be exited from the machine. Okay, so now in the VM list here, now in the VM list we have introduced these parameters. First one is the ID. The second one is the user ID. Means every time virtual machine has its different IDs. Now MIPS part, which is uh, speed of the instruction, speed of execution of the instruction, means every time a new instruction, new cloudlet has come, it will take around some milliseconds. So for to calculate that part, we have introduced this function. Okay, MIPS plus I into 100. It will be multiplied. This 100 is the threshold value. Okay, we have calculated this in the previous lecture. Okay, so now PES number will here you can see PES number is the core CPU part, means the CPU will be aqua or CPU will be octa according to the parameters of the virtual machine. Here it will take automatically. Okay, now the third parameter is 256, because every time a next integer will take from the random number will take from 0 to 256 value, means every time it will going to bit by bit. So for 1 byte 8 bits are coming. So because of that we have calculated 256 value. It's just the calculation part here. Now I am coming to the second one, the cloudlet part. Now we have created cloudlets using this function create cloudlet. Okay, now after creating the cloudlet, we have to store this cloudlet into the container. Okay, so for that we have decided the cloudlet parameters, where the length of cloudlet is 1000 and the file size included in the cloudlets are 300, and the output size is 300. After that, PES number, it's the CPU number of CPUs, uh, which is equal to 1. After that, utilization model has come. Utilization model is it's a function which will see which will be means how much system is utilized. Okay, means for the entire algorithm, how much system is utilized, which will show us the energy consumption values. Okay, so now I am coming to the this is the random number generation only. Now this is the main function. Two data centers are there, data center 0 and data center 1. Now data center broker FCFS, because this is an FCFS algorithm, so we have created data center broker FCFS for this. Now see, we have created virtual machine, 5 virtual machines here. You can exceed this value. Okay, so here I am just including 15 virtual machines to see if to see the variations, how much variations will be in the my membership values. Okay, so I have taken 15 virtual machines here and 100 cloudlets are there. You can increase this number of cloudlets. So I am just taking 1000 cloudlets. Okay, now after saving this, I will run this again. I will run this again. So run. Okay, so this is the FCFS results, and the it will take, because every time the cloudlet, each cloudlet is taking different values, and it will be calculated in the milliseconds. Okay, so 8517.55 milliseconds are, so these are the values are, these values are calculated in the milliseconds, and 8517 is the millisecond taken by FCFS algorithm to run this task. Okay, so now, yes, now there is an interesting FCL file, because here we have introduced the compact fuzzy logic function. So every time you don't have to use the same function like trapezoidal function. So we have introduced the new functions here. You can see here I have used uh, because this is an example for this. For an example, I'm taking the different. It's not a. It's in a gravity function. Okay, the gravity value is calculated using this function, center of gravity. Okay, so method will be COG, means it's in a center of gravity. So in the results, we are getting COG values different. And see, this is an activation method, and this is the maximum accumulation method here in the FCL file. Okay, so here you can see the memory constraints, 5 memory variables constraints, memory, bandwidth, disk, and 2 more we have included. The fuzzy constraints we have included, 2 more fuzzy constraints we have included in this. For this, we calculate the fuzzy membership value. Okay. Now I will again run this task. Yes. So you can see for the trapezoidal function, these values are coming after changing the virtual machines, number of virtual machines, and the number of cloudlets. We are getting these values. So it is different. Means the previous task, the previous membership values are different from the current membership values. You can see the variations here. Now I will remove this part and I will show you the, yes, see. So these are the membership functions. Yes. So every time a weight is calculated for each membership function, means if a new like in machine learning, if a new node is assigned, a new weightage is calculated. Similarly here, and every time a new function sk, the weightage is decided according to the algorithm. Okay. Now I will run this SJF part. This is the shortest job first algorithm. Okay, so we have compared the optimized fuzzy load balancing algorithm with the shortest job first algorithm and the first in first serve basis. So these are the allocation policies, different allocation policies. You can take max min also. So first we run this SJF part. Yes. Now you can see it's the total execution time is 770 milliseconds. It is very less. Okay, but it is very less time. But whenever we add the fuzzy membership functions here, and according to the variation, we get the smallest variation time. Okay, every time you can see the variation is very minute. 33466.89 milliseconds. It's very minute. Okay. Now, for the SGA function, this is the code for the SGF algorithm. Okay, in this code we have changed this value. Now see, we have created available VM and busy VM. This new list is indicating the available VM, how much cloudlets are received by the list, and this new list one is indicating the new created VM list, which is available VM. Okay. Now for the execution time, we take the difference between the start time and the finish time. So it is very easy for us to calculate the execution time in the SJF algorithm. Now coming to the data center broker FCFS part. Okay, so for the to create the data center broker, because it's very essential to provide the cloudlets to the data center broker, because it's the mediator between the virtual machines and the cloudlet parts. Okay, the cloudlet will are not directly assigned to the virtual machines. There may be a data centers, hundreds of data centers are there. So we have to decide which data center part will be occupied first, and which virtual machine will be assigned. So for that we have created data center broker FCFS. Okay, so these are the methods: VM list and VMs created list. So these are the methods we have created in for this program. And for the VM status, we have created this VM status function. Now coming to the main function here, data center broker FCFS. So first we set the variable. Okay, now we decided, first we set these available variables, means whichever variable values we are using, first we set these values, and then we provide these values to the for the output. Okay, so now coming to the next part, this is the process event. Okay, so every time a process is triggered, so this will check if CloudSIM has resource characteristics request. If there is any resource, we can check the EV value. EV is an object. Okay, so every time we check if there is then any resource allocated to the machine or not. Similarly here, it will check the resource characteristics, means the VM characteristics are there. Okay, means VM ID, VM value, means it will check the function labels available for us for the virtual machines. Okay. Now for the VM create acknowledgement part, means a VM is allotted any task, will acknowledge the data center broker that a process is assigned to virtual machine. Now this is the clouded return part, and for the end of the simulation, these tags are used, CloudSIM tags. Okay. Now this is the process resource characteristics, because it will this value will be used in data center broker characteristics part. Okay, I will show you data center broker characteristics part. Now see, data center broker. Yes, so this is the data center broker code here, which is used in the CloudSIM. Okay, and we have changed this scheme, the resource allocation scheme, to the first come first serve basis. So this uh, entire code will work according to the VM allocation scheme. So for the SCFS part, we have used data center broker FCFS, and similarly for the FLB part, means fuzzy logic part, we have used the data center broker FLB. Okay, so here this is the data center broker FLB part, and anyone if any doubt, you can ask during the execution of the program. If you have any doubt, you can ask in the chat box, or you can ask directly. Okay? So because we have less time, so I'm not explaining one by one, I'm just explaining which methods we have used and which allocation schemes is performing better. Okay, so now you can see here, now this is the main process cloud return part, where how process are so we have seen the process allocation and deallocation. Two algorithms are there. For the process allocation scheme, this method will run the process clouded return. Okay, so now if VM ID equals to clouded dot get VM ID, every time a new virtual machine is assigned, it has some ID. So this method will check if the ID is allotted to the VM or not. Similarly, it will check if ID is not allotted, then error message will be returned. Now coming to the cost of VM, which how much cost is assigned to the VM. So now you can see memory used, VM get RAM method is used here. Similarly, for the size, VM get size method is used. Similarly, for the bandwidth also. Now, for the to retrieve the data center characteristics, we have initialized the data center object here, data center, and the data center characteristics are initialized. Okay, every time a new data center is assigned, the cloudlet will directly go to the virtual machine. Okay, the data center broker will tell which virtual machine is available for us and which are busy. Okay, now I will run this code again. So before going to FLB part, we have these max-min algorithm also here. I have introduced max-min algorithm. For that, data center broker max-min FLB. Okay, so this is a max-min algorithm. I will show you the max-min here. Yes. Now this is the max-min algorithm. Okay, so for this max-min algorithm, we have created virtual machines. In this, the available list are there, and we have decided the MIPS value, which is equal to 1000, and the random number is calculated using new random function. And for that, these tools for the network latency part, we have introduced a new random function R, and R will calculate it will take random values for the network latency and security, because we are calculating these values, and we according to these values we calculate the threshold functions. Okay, so now we have introduced these three functions here, new functions. These are the dynamic function, dynamic bandwidth function, dynamic latency function, and the update attributes. Means every time a new bandwidth, every time the bandwidth has changed, the dynamic bandwidth function will calculate the bandwidth values. Okay, because it will control over the bandwidth values. So we have introduced dynamic bandwidth function here. Similarly, dynamic latency, as sir has already told you about these in the lecture. Now, for the cloudlet creation, we have introduced a new variable, create cloudlet here. This method will calculate the cloudlet values, okay, and directly assigned to the data center group. Similarly here, it is already been covered. Now these are the functions. Okay, these are the functions to calculate these function, like dynamic bandwidth selection, initial bandwidth into network latency divided by time. So it's these are the dynamic functions here. Okay, for the dynamic latency selection, network latency into 1 plus security by 10. So these are the formulas which you can see in the paper, because this is paper has been already published in the read form. So these values are calculated in the paper, and I am directly telling you here by running this code. So this is max-min scheduler. So to handle this max-min scheduler, these two methods are taking care of this, because max-min scheduler, every time scheduler has come, it will decide which are the maximum values and these are which are the minimum value. Means every time it will the scenario has been changed. Means every time a new allocated cloudlet has come to the virtual machine, it will directly go to the max-min scheduler. Okay, and it will ask which virtual machine has been assigned. Now I will run this code, CloudSIM FLV with max-min. Okay, so I will run this code here. Now you can see here. So because there is no more future events, we can directly see the status of the VM. Okay, you can print these statements in the blocks, or this is only a log file. This is only a log file. It will not print the result like previous algorithm, because we have introduced a max-min scheduler. The scheduler is different. Okay, now for the LST part, because this is different algorithm. Now I will run this. Now see, the total execution time is 5335 milliseconds. So according to the number of cloudlets and according to the number of virtual machines, it will take around 5335 milliseconds, and the VM allocation policy is different. Okay, so how we are handling the entire scenario using different algorithms. Okay, so there are so many algorithms here. So I will again run a new algorithm to see the variation of the program. Okay, the code is same, but the number of virtual machines and the number of cloudlets are different, and to see that how much variations are coming. So it will take around some time. So is my screen is visible? Is my screen is visible? So the scenario has been changed because we are using an hybrid cloud here, and we have changed this because it will take some time. So before completing this, I will introduce two new things here. It will take some time here. So in the meantime, we will see VM allocation policy, which is a different thing. Okay, so every time we are changing the allocation policy here, and elastic cloud date. So for this program, we have introduced this elastic cloud date part, which is the again a different algorithm, and for that we have introduced a public method elastic cloud date, and each time it will calculate the deadline part, and for to set the deadline part we have introduced a set deadline method. Okay, so now data center broker, now see, it will the HCFS part is taking 110795 milliseconds. Okay, so because the number of cloudlets are around means uh, 15,000 to 20,000 cloudlets are there, it will take some time, like 110795 milliseconds. So according to the simulation environment, we are changing the parameters, and for this we have introduced new fuzzy rules, and for to calculate these fuzzy rules we have gradient algorithm is there, and now coming to again the FLB part. Now this is an optimized fuzzy based load balancing scheme, so it will run fast. Okay, so it will run fast because we have introduced fuzzy constraints here, so it will run fast, 378 milliseconds. The FCFS will take some last time, because every time the function the cloudlet which comes first will take the entire execution time. Okay, so now this FLB time is very less. Now the SJF part, it will also take some time. Okay, SJF part will also take some time, but to run this it will, yes, 9 to 4 milliseconds. So it means our algorithm is performing better in comparison to the SJF, shortage job first algorithm, and the shortage job first algorithm is taking lesser time in comparison to the first come first serve algorithm. So this is the simulation environment, and these are the running code of our paper OFLB, and this I will run this code again. Okay, to understand how these allocation schemes are working. Now see, again I am running this. Now you can see the least scheduling time. Okay, LST means least scheduling time, which is taking 4389 milliseconds. Means our algorithm is performing better than max speed and LST algorithm and SJFN, because these are the traditional algorithms, and they will take much more time than OFLB algorithm. So our algorithm is performing better in comparison to traditional algorithms, we can say, because it is simulated on the cloud sim environment. You can see here. I will again take different scenario and run this environment. Okay. So every time I'm changing the number of virtual machines and cloudlets, and check if our algorithm is performing better or not. Okay. Now, so see, these are the VM attribute. Okay, these are the VM attributes part. And for the new variables, network latency and security, I have calculated this. These are the values for the VM attribute part. Now I will close this and again run. Yes. Now I will again run this part. Now see, for the linear regression best fit values are coming here. You can see here, and for the VM allocation here, yes. So every time our linear regression values are also calculated, and the average response time you can calculate. And according to the functions, we have calculated the overhead. Average overhead value is 24397.42937. So these are coming the overhead value. Migration time is 0. Scalability is 12.5. Fault tolerance is 1.0, and reliability is 1.0. Again, accuracy is coming. So every time you can check how much overhead is there, how much response time is there, and energy consumption is 0, because here we have not included an energy part here. Okay, so you can introduce an energy consumption function here to calculate the energy part here. Okay, so for that, because this in this CloudSIM part, yeah, there are so many files. In the left column you can see 4 values, and for the data center, for the network here. Now these are the topologies and the cloudlet list, PE list. These are the distributions, these are the predicates, and for the power list here. Now it will introduce the energy consumption part here. Okay, so you don't have to take another different functions for to calculate the power. It is already been calculated using a power data center. Okay, the power data center will calculate the characteristic, data center characteristic, VM allocation policy. It will take, you can change the allocation policies and storage area also. Okay, so now we are focusing on 3 things. Now the scheduling algorithms are there, which means FCFS, SJF, and OFLB, and the allocation strategies, like how much cloudlets are there, how many virtual machines are there, and what are the new concept introduced in this simulator. So we have separated the queue and available VM list and the busy VM list. So according to the algorithm, we have decided which are the threshold values for the high fuzzy constraints. Okay, now again come to the, yes, example. I am again running. Yes. So now see, the FCFS is taking make spend time for FCFS algorithm is 179,930 milliseconds, which is very large. Okay. So and average utilization is 0, because we are not utilizing uh, resources for this algorithm right now, because this is an different area, and for that resource utilization, we have to make a different function which is covered in the different file. Means we have covered this in the different packages. Now the migration time is 70.4 milliseconds. Okay, and the average response time is 664.712 milliseconds. Okay, so now we can see here the FCFS is taking much more time. The make spend time of FCFS is very large, and the response time is also very high. So we can say the OFLP is producing better results in terms of make spend time, in terms of response time, and in terms of migration time also. FLB, CloudSIM FLB is performing better in comparison to traditional algorithms. Okay, so before going to next thing, and I would like to perform some Jython codes here. Yes, so these are the Jython functions, Jython code. Yes. Jython means it's not a Java and it's not a Python. It's a mixture of both. Jython and means Java and Python, because CloudSIM is particularly based on the Java file. So we we find out a new method to calculate these resource allocation values by using a Python. Means we are introducing a new concept here. Now you can see uh, we have introduced this FIS fuzzy chart, and to introduce a machine learning in this area, we have used this Jython code. Now you can see here the population size, because this is a genetic algorithm to calculate the threshold values. Okay, because this is your question. Maybe this is your question, that how you calculated the threshold values and how you decided these values are working. Means the values you have calculated in the slide may be different from the values you are showing on the screen. So we have run this algorithm Jython code here to calculate the threshold values. Okay, so I will run this code. I will run this code, and it will calculate, give us the threshold values. Okay, so Jython run. It will take some time. Yes. So because this simulator is taking very high load on system, so it will take around 1 or 2 minutes to run this entire code, because there are so many files in my project. Now you can see here we are calculating these threshold values using a genetic algorithm. Okay, yeah, you can use different algorithms also. The gradient algorithms also are also there to calculate the fitness function. Yes, you can see the fitness over generation. It is very means uh, now see, there is only variation between 70 to 80. It looks like it's in a horizontal line, but it's not an horizontal line. It's not an horizontal line. You can increase this and see this. There is a very little variation between 70 to 80. Okay, I will close this. This is an introduction of machine learning in cloud sim area. Okay, so because without machine learning, we can't directly calculate the threshold values here. Okay, so we introduced the machine learning part and deep learning part in my code, and for that we have calculated the threshold values. You can see the calculation part is done. Now I will again run this code. By changing some parameters, you can see, yes. So this you can see this is an Jython code here. So is my screen is visible? Is my screen is visible?
Yes, sir. Your
If
screen
you
is
if you
visible.
have any doubt, you can ask in the chat box, because it's a Jython code. It will take some time. Now see, this is the memory versus bandwidth. So these points are showing the values uh, comparison of two fuzzy constraints, memory and bandwidth. You can see the 3D scatter plot is uh, introduced here. Means every time you can see how memory and bandwidth functions are changing. Okay, so we compared these two parameters and then see how these are varying, how these memory functions are varying. Okay, so now this is the fitness over generation. Okay, so this is the uh, introduction of genetic algorithms in to calculate the threshold values in the OFLB paper. Okay, so you can use different algorithms. There are so many, because so many algorithms I have seen in the simulator I have run. Now I will close this. We will provide this code to you, and after evaluation is done, because now, yes, every time I'm changing, I'm learning a new parameter has came, and we have to calculate the threshold value for this. So we have to change this code again, and we have to run and check if there is any variation between these. Okay. So every time we are checking the relation between memory, bandwidth, disk, and two more constraints we have used, like network latency and security part, because for the cloud security purpose we have introduced a new variable security here. Now here, now you are seeing the cloud sim properties here. You can see there are so many files in the simulator, and every time we have to change these files according to our simulation. Okay, now see the results. So this is the bubble chart of memory versus bandwidth versus VM status. The bubble chart you can see here, and these are the optimal values we have calculated uh, for the VM parameters. The optimal values means every time these optimal values will change, but the you can see here the we I have to again run this code, because sometimes we have to check the values are coming properly or not. Okay, so every time you have to run to, or you have to run and check if there is this relation between memory bandwidth and these fuzzy constraints are running properly or not. Okay, because these methods will calculate the random functions every time. Okay, so I will run this code again and check the results. Now see, it will take some time. It will take some time. So for this I have now see the optimal values are coming for the memory 61.7795. This is the memory value, means these are the threshold values we have calculated using this algorithm. But here you can see you can neglect this security value, because we are not introducing this security in this OFLB paper. So the memory value is 61.77951 and the bandwidth value is 23.322. You can check these values are varying according to the virtual machine parameters. Okay, so now again I will run the next code here and uh, see the scatter plot and the counter plot. You can use these plots to see the variation between these memory and bandwidth, because every time the disk is not taking the whole time. Every time we are changing memory and bandwidth to see if bandwidth consuming is more or memory consumption is more. So for that we have to check if memory is very low or very high. Okay, now it will take 1 or 2 minutes. Now you can see here, now security part you can see here 1.727, and every time now these values are working very fine, because memory value is 57. So these are the threshold values. Now these threshold values we included in our code. Okay, so these are the threshold values we calculated using the gradient functions, means genetic algorithms. Now in these values we have used in our algorithm. Okay, so now coming to cloud sim FLB paper. Now yes, now these are the threshold values, and now I again run this code, and for the example purpose we have written here. Yes, now see the variations are different. Okay, so every time you can ask how these values are calculated. I'm removing these two parts and showing only the results which we are getting by running this code. Okay, so these are the values we get after running this algorithm, and every time you have to check the variation between the membership values, and after comparing the results of OFLB with the traditional algorithm which we have seen in the simulator also, OFLB performs better rather than uh, another traditional algorithms. Okay, so this is part of our research. Now we are extending this to another simulator, because this is the work we have done, but this is not means this is not the entire cloud area. Okay, we are going to iFox sim here for the cloud security purpose. We are going to the iFox sim. This is a different simulator here. So I will run this code to check. Okay, now here I will run this code. Now see, the hundreds of files are there in this simulator, and every time we have to change these. Okay, now for that I will see where I have changed here. Okay, for the HDN purpose, we have introduced these files, and for the example purpose, now you can see these are the VM share, allocation schemes and VM uh, uh, allocation policy schemes which we have used for the security purpose, because the simulator is different, so it will produce different results. Okay, so hundreds of files are there, so because we don't have much time to explain each one of them, so we directly go to the FLB part here. Now this is the FLB code. So this is FLB code here, and you can ask anything regarding this paper. And if you have any doubt, you can ask me. So let me stop this slides. Yes. So if you have any doubt, you can ask me in the chat box, or as I have stopped my stop the screen. Yes. Am I audible?
Yes, sir, you are audible.
Yes. So we can.
Participants, if you are having any doubt, you can put up in chat box. We will convey the message. So, sir, I think there are no doubts.
Okay, so thank you for the entire session, and I would like to again thank you, my guide, my supervisor, Dr. Mushtaq sir, and because he has given me opportunity for this entire for this wonderful FDP. So thank you to all the participants, and if you had any doubt, you can reach me to my LinkedIn profile. You can search my name on the LinkedIn, and you can reach me out there. Okay. So thank you to all of you.
Thank you, sir, for such wonderful insights on how the CloudSIEM works and all the demonstration. Participants, please note that for tomorrow, the first session will start at sharp 9 due to some time constraints from Dr. Anurag sir. We will be sharing tentative schedule also. This is only for the tomorrow case, and from day after tomorrow, it will be 9:30 onwards. Tomorrow, it will be starting at sharp 9. Okay, so we will be ending the meeting now. Please do come at time at tomorrow, because at 9 we will be starting sharp.